All right, so we did 47. We used the distance formula. We used the slope formula. We did all this kind of work, and then after we got our answers, we went back to this chart that we talked about to find out and prove what shape we had. All right, so let's go on to the next one. We are going to see if we can prove that a quadrilateral is a rhombus. That is number 48. So let's go ahead and start plotting this out and see what we get. All right, so here's our graph. Of course, this is our y-axis. This is our x-axis. Got some arrows on the axes, very nice. So B is -2, -3. So -2, -3 is down there. That's B. I is 1, 1. 1, comma 1. 6, 1 is R. So 6, 1. So it's 2, 4, 6. 2, 4, 6. Yep, 6. Oh. 6, 1 is actually right here. That is point R. This one was point I. And then the last one is 3, -3. So that is D, 3, comma -3. So no doubt it looks like a rhombus. But that's not good enough. We have to actually prove that it's a rhombus. All right, so let me go on in here. And we know that we are going to look at the diagonals. So we're going to look at this diagonal here, ID. And we are going to look at this diagonal here, BR. All right, so let's start it off with the distance. Distance definitely the tougher one. D equals the square root, the whole big square root of x2 minus x sub 1. All that squared plus y sub 2 minus y sub 1, all that squared. Now we're going to do that for the two diagonals. So the first one is BR. And we're going to be using point B, which is -2, comma -3. And also we're going to be doing, what are we going to be doing? Oh, point R, of course, which is 6, comma 1. And then let's see, we're going to also work with ID. And point I is 1, comma 1. Point D is 3, comma -3. That is a D, by the way. Very good. All right, so let's go ahead and get this going. So I always like to first identify my points. That keeps everything nice and clean as we work. Now I'm going to simply go back and I'm just going to start plugging stuff into the formula. All right, D equals big old square root sign, right? So x2 is 6 minus -2 squared. Watch that double negative there. We then have 1 minus -3. Again, another double negative. So watch out for that one. So D equals 8 squared plus 4 squared. Now, it is a good idea to leave those in parentheses. That's because if you have a negative number, when you square it, it's always going to come out positive. So let's see what we got here. So next line, D equals 64 plus 16. All right, 64 plus 16, square root of, that's going to be 80. All right, and we do not need to take it any further than that. We could just kind of leave it there for the moment. All right, next up, let's go to the distance formula again. So D equals, and I'm just going to move this up a little bit, the square root, and x sub 2 is 3 minus 1, all that squared. We're going to add to that -3 minus 1, all that squared. All right, so let me just double check, make sure I had that right. 3 minus 1, that's good. -3 minus 1, that's good. All right, so D equals square root again. So that's going to be 2 squared plus -4 squared. There's that negative that we're squaring. All right, so D equals 4 plus 16, which is the square root of 20. So the diagonals are not congruent. Not congruent. So diagonals, not congruent. All right, very good. Now let's go to the slope and see if we could find the negative reciprocal. So to do that, we're going to start off with the slope. Remember, the formula is m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. All right, so let's do it. So first one, we have that BR. So BR is the first one we have to find. And B is negative 2 comma negative 3. The R is 6 comma 1. Next up, I'm going to go over here for line ID. And we have I, which is 1 comma 1. And we have D, which is 3 comma negative 3. Very good. And then it's just time to start chugging away with the formula. So let's go for it. So if I do that, slope equals y2. Oh, I didn't identify my points. All right, so that's x1, y1, x2, y2, x1, y1, x2, y2. I gotta tell you, it's such a simple thing, but it really keeps things in order. All right, so we're gonna say 1 minus negative 3 all over 6 minus negative 2. Again, watch those double signs. We're gonna get 4 over 8, which is 1/2. All right, very good. We go to the other one, to the other side. Same deal, slope equals y sub 2, which is negative 3 minus 1 over 3 minus 1. All right, so negative 3 minus 1, 3 minus 1. That is going to be negative 4 over 2. And that is going to equal negative 2. And just for the record, by the way, you know, negative 2 you could write as a fraction, negative 2 over 1. Now, if you look at these two numbers, notice that they are indeed negative reciprocals. Reciprocals. So therefore, since they're negative reciprocals, that means the diagonals are perpendicular. So, from what we just found out here, let me just get the highlighter here. We found out over here, the first thing we did is we found that the diagonals are not congruent. However, the diagonals are perpendicular. So diagonal is not congruent, but the diagonals are perpendicular. So let's go back up to the chart, way up here. So the diagonals are not congruent, right? Not congruent, but they are perpendicular. So therefore, we do have a rhombus. Very exciting. So let's go on back down here, and we're going to say the shape is a rhombus because the diagonals are not congruent, but are perpendicular. All right, so there is my final answer. All right, very good, very good.